So yeah, pretty much all the things that Paco said, but if you're interested in the slides from today's talk, I will try and put them up on my slide share. So if there is a slide you want to take a picture of, this is the slide, so go ahead and do that now. You can take pictures of the other slides too, but like just in case they don't come out, this is probably the one for you. My preferred pronouns are she or her. I'm currently at Alpine Data Labs, and like Paco mentioned, we work together at Databricks. You can also follow me on Twitter. If there's not enough pictures of cats in this talk and you want more whimsical pictures of cats, definitely follow me on Twitter. Cool. So I'm going to talk about a bunch of things. We're going to start with like who I think you are, besides like awesome people. I'm going to do a bit of a pitch on why you should test your Spark programs, but I mean, this is kind of preaching to the choir since you actually bothered to come to a talk, so good job, everyone. And then we'll dive right into actually, testing our Spark programs, and we'll look at some of the sort of considerations we need to test streaming programs, along with Spark SQL and Dataframes, because they can be a little bit more complex. And then we'll also talk about doing sort of acceptance tests or validation of Spark jobs as well. There will be cute and scary pictures. I have done my best to not put them on the same slides so you don't get confused, and so that my stuffed animal, Boo, does not get confused either. I promise at least one picture of a cat and one picture of a panda. I think I might over-deliver on this promise, but that's at least what we're going to get to. So I think you're all really nice people. You came to my talk, so clearly that's true. If you're not, I don't want to know. I'm hoping you like silly pictures. If you don't, you should ignore the top corner of the slides, and the rest of the content will be pretty normal, insofar as content that I produce is normal. I'm hoping you know Apache Spark. How many people know Apache Spark? Oh, thank God. Okay, cool. I left out my standard, this is RDDs and stuff spiel, so that's great. If you're watching a recorded version of this maybe and you don't know Apache Spark, Paco has a really wonderful video training series that you can go check out, and the Learning Spark book. Obviously, I'm a little biased, but I think it's pretty cool too. I'm hoping you know Scala, Java, or Python. If you're an R developer, this probably isn't super useful to you, but if you know R, I'd love to chat with you about sort of how we can bring some of this testing infrastructure to the R world as well. And I'm hoping you want to make better software, or at least are not, against better software. So why should we test? It makes you a better person. In addition to attending this talk, if you actually go and write tests, you will definitely be a better person. It'll save you money. Probably by helping you avoid losing all of your employer's money. If we were still in the Bay Area, I'd say users, because they don't have money, but here in New York, we probably care more about money. AWS is expensive. Even your in-house clusters are kind of expensive, so tests allow us to catch things earlier, rather than running our job and realizing it failed. So if we can test our code, we don't have this really long wait. So yeah, we get faster dev cycles, and that's more awesome. I'm really just trying to give you flashbacks to your QA internship and remind you that testing is really important. How many people were QA interns of some sort at some time? Okay, way less than I thought. Well, so for those of you that didn't get the flashbacks, these things are still important, and I'm sorry we don't have the flashback for you. But you don't want to get on the fail boat. The fail boat is a very sad boat, and if you don't write tests, you're going to end up on the fail boat. So, even though we all sort of know that we should be testing code, like you showed up here, we often don't. And that's because testing is hard. And I think it's hard for a bunch of reasons, especially with Spark. I think some of the biggest stuff is that faking our data is really challenging. It's no longer just a few strings that we're going to feed in. It's actually kind of a lot of work. And when our boss is like, hey, is it done? We're like, well, yeah, just there's no tests. And they're like, okay, ship it. And that's bad, right? So we should stop saying it's done before the tests are done, because that's just the path to sadness and getting woken up at 3 o'clock in the morning. Okay, So I've done my best job of convincing you to test. Thankfully, you all bothered to show up to a talk on testing, so it didn't have to be a very good job of convincing. But this cat is the signifier that we're gonna get down to business. It's time for work. Just like this cat is off to work in its very cute hat. Okay, so let's look at what a simple Spark unit test looks like, right? This is a hand-rolled artisanal Spark unit test. So just like the artisanal roach bombs, we have a bunch of things that we're gonna do for making a artisanal Scala Spark test. The first thing is we just need to make our Spark context. And really the other parts shouldn't be particularly surprising, except for this one bit here, where we're clearing this spark.driver.port thing. And that's just so that when we set up and tear down our Spark context repeatedly, it's not gonna try and bind to the same port and have challenges. So, if you wanna hand roll Spark tests, this is the work you need to do to set it up. But it's not that much work, it's okay, right? Then we can write our actual test. I did say, it would be more than just strings, but for the purpose of a slide, we just have our input, which is gonna say hello and then bye. And then we just, write a pretty standard assertion, right? This is just, standard testing bits. The only thing is we had to write this boilerplate code. And it's not a lot of boilerplate code, but I think part of what has made Spark so successful is the fact that there's libraries for pretty much everything, and they ship with Spark, right? You don't have to go out and get a separate SQL component. But for testing, we have to write our own testing boilerplate. And it's gonna get more troublesome when we go into streaming. But we can go and get batteries from not Radio Shack, because they're bankrupt, but pretty much anywhere else. There's some really cool libraries for unit testing that we're gonna dig into today. There's Spark Testing Base, and you'll note that my name is in the GitHub for it, so I'm a little biased, so I think it's pretty cool. There's SScheck, which is a really cool Spark testing library, which is focused around Scala check, which we'll talk about. And then we'll also cover some other things. Yeah, you got a question?
Yeah, I don't post this. I going to share the deck.
Oh yeah, I'll share the deck. I'll post it to my SlideShare and I'll also tweet it. Don't worry. Totally cool. So you don't have to take pictures of every slide, but you can if you want. It's quite all right. It makes me feel like a rock star, so that's fine. But this is pretty much the same test that we had before, except now we don't have our slide of boilerplate code. It's pretty simple. We're still using parallelize to take this small set of strings, and then we're just collecting it back and using our existing unit testing stuff. In Java, it actually takes up the full slide, but once again, it's pretty simple, right? All of the Spark bits are sort of handled for us, and we can just write this as if we were testing a regular program. And in Python, there was enough room to even add docstring comments, because it's Python, but it's a simple test. But so that sort of only really works if our test data is some strings that we can just bang out by hand, right? And probably, for most of you, that's not going to be the case. You actually need to test more than 3 inputs. So we can do a few things. If you can downsample from production data, go ahead and do that. I think it's one of the best ways to get test data. I've worked a lot in search and recommendation systems. When I've worked in search systems, I can always downsample from production data. And when I've worked in recommendation systems, the lawyers have said that they will come and find me. So check with your local legal team before including it in your repo. But if you can, it's great. The other one is we can just make these lists, or we can go ahead and use fancy libraries. One library that I think is really awesome is Scala check, which is derived from Haskell's quick check. It's more of a port than anything. And it generates test data. So we can actually specify sort of what our case classes are gonna look like, and it'll generate a bunch of test data for us. SScheck, which is one of the projects I was referencing earlier, actually does this to directly generate RDDs. And they also support D-streams, which is really cool if you want to do streaming tests. Spark Testing Base, also generates RDDs. It doesn't do D-streams, but it does generate slightly more pathological RDDs. When we're using parallelize locally, Spark does a really good job of splitting the data up fairly. which is great for like actual computation, but for when we want to like test our code and find corner cases, we actually want to probably make some more sort of pathological inputs, and that's one of the things Spark testing base will do for us. So with SScheck, we could do pretty much the same thing. Sorry, not pretty much the same thing. We could do something like this, and we don't have to write down our strings that say hello and goodbye to me, but we just say like, I want you to generate some arbitrary strings, and we could specify a bunch more things about the strings. We could specify that we were generating case classes. We can do like pretty much whatever we want. And it'll make RDDs for us, and we can specify this invariant, and it'll like automatically try and find RDDs which our code fails on, which is pretty great because, you know, when I'm writing tests, I'm often pretty tired, and like thinking of the corner cases is hard, so having someone auto-generate them for me is amazing. And we can do the same thing with Spark testing base. It just has like a slightly different signature. You know, I wrote this one, so I think it's cool, but like I'm incredibly biased. So either way, right? Like I think both these are cool. So, you know, we've sort of looked at testing regular Spark programs. It's time to move on to the exciting world of testing streaming programs. So we have a stream of lava coming down the mountain to destroy our code, and it's kind of terrifying. So why is it a stream of lava? Well, it's a stream of lava because if we wanted to write our tests by hand and we didn't want to use a library, this is just the start of the code that we have to start writing. We need to create our own custom input stream classes because queue streams don't work anymore after 141 for certain types of operations, namely windowing and checkpoint operations, which, you know, are pretty, you know, crucial to a lot of streaming apps. We have to create a manual clock or sleep for like k seconds, and whenever I see test code with a sleep inside of it, I either want to cry if I wrote it or murder someone if they wrote it. And yeah, now for the manual clock. So we need to like write this manual clock. And not only is this code kind of boring, we have to lie and say we're inside of Org Apache Spark when we're writing it because of, you know, some things. So we can just pretend everything's okay, just like these pandas that are coming down, and we can you know, just go ahead and ignore all of these problems and instead just use test operation. So I mean, if you do want to do it by hand, like it's okay. I don't think any less of you. I think you're maybe a little adventurous would be the word, but you know. It's doable, but there's no good reason to write like 6 slides worth of code every time we want to do a streaming test when we can just write this, right? This looks like we're testing just a regular program, right? We specify our input, our expected output, and then we just, you know, say test operation on it. And there's pretty similar things for also generating D streams with the SScheck people. So you can write similar type codes and not even have to write your own input and expected outputs, just specify some invariants. So, okay, cool. So we've covered streaming. Streaming's pretty rad, but data frames are also, you know, how many people use data frames actually? Cool, okay. I probably should have asked this, but how many people use streaming? Okay, cool, pretty good smattering. Okay, so, you know, another thing that we were going to want to do is test with data frames. And we might even want to test data frames with streaming together for like all kinds of extra excitement. But we can do this pretty simply. The problem is there's no real simple built-in way to say if 2 data frames are actually equal in a meaningful way. Inside of Spark, there is this check answer function, which is unfortunately not exported. But it's actually pretty good, and it's what's used for a lot of the internal Spark tests, and it checks a data frame against a sequence of rows and says like, is this more or less what I was expecting? On the other hand, I find it a little weird that we'd write our expected data as a sequence of rows and like our result as a data frame. So I went ahead and I just made equals data frame that instead just like asserts that the 2 data frames are the same. And so in addition to comparing the rows, it also allows us to compare the schema in a more reasonable way. This test is pretty trivial. A data frame should be equal to itself if this fails. This is, you know, things have gone pretty off the rails. But you could see yourself using this to test, like, you know, more complex things, right? We could be transforming input around, and we could have manually specified what our results were going to look like. Or we could be comparing it to some RDD transformations. So, okay, I've talked about a lot of really awesome and happy things, but while I've been doing this, I've been hiding something from you, just like I'm assuming these cats have been hiding the fact that they ate all their food from the owners. And that's local mode. And so I'd like to start off by saying that local mode is not actually all that bad, right? Like, Spark local mode is surprisingly good, especially if you look at like MapReduce local mode. Spark local mode actually has multiple reducers. It actually tests all of the serialization stuff that you're going to get, you know, in a real sort of environment. Or, well, it tries to, and it does like a good 99% of the way there. But just like all local copies of distributed software, sometimes shit only shows up. Only shows up in production. Sorry. Yeah, so it's not the same as running in a real cluster, but that's okay. We can take all of the testing methods that we've been using so far, and we can go and have them run on a real cluster. And there's a bunch of ways to do it. The easiest way is to write a bunch of shell scripts in cry. And then, you know, you'll have your shell scripts, you know, spin up a cluster at the start, and like, then you can just go ahead and point your master at the cluster that you've started with your shell scripts. It's pretty great. On the other hand, if you don't like writing shell scripts, like a sane person, you can go ahead and look at using some other alternatives. There's Spark Docker, which is pretty cool. Sorry to the people that love shell scripting. You know, it's not actually bad. It's just easy to poke fun at. There's Spark Docker from the Databricks people, which is really great. Its only problem is that it's sort of focused on testing Spark itself and less testing our code. But you can take a look at it, and you can either use it as a basis for your own tests, or you can just like fork it and add some of your tests on top of it. Another option is using Yarn mini cluster. Now, much like streaming, you could go ahead and set this up yourself. Doing it is an exercise in frustration, as indicated by what I was doing last week. But it's doable, and we can actually run Spark on a sort of Yarn mini cluster, which gives us many of the benefits of testing on a real, actual production cluster, but without all of that expense of buying 13-inch CRT monitors. You shouldn't actually use this until after Spark 1.6, probably. There's a pull request I've got out to make it so that you can switch in between Yarn and other modes while still keeping the same JVM environment, but it's not in any of the current releases. If you do want to use it, though, you could just fork a new JVM, but it'll make your test kind of slow, which is less than ideal, but completely manageable. So we've talked a lot about testing, and I'm going to use this as a quick opportunity to drink some water. But we're going to move on to validation. And I'm going to make a lot of clinking sounds. Cool. So testing is, in my mind, and like, to be fair, I might not always get words right. I love the word pandas, and it means pretty much anything. So when I'm talking about validation, what I'm talking about is checking that our jobs are actually running in a reasonable way. We can test our code, but the real world is always more ingenious than I am at finding ways to make my code fail, right? And it's probably going to happen to you unless you write really trivial code, or you're like a genius, in which case that's cool. But for the rest of us, you know, we should try and detect when our code's failing to avoid having it do even worse things, right? It's a pretty simple idea, and it's not all that hard to do, but for some reason, not a lot of people seem to do it with their Spark jobs. I'm not super sure why, but like, if we don't do it, right, we could make terrible recommendations. You know, maybe someone is going to change the meaning of a field on us, and then, you know, all of a sudden, all of the content that we thought was age-restricted is no longer age-restricted content, and we start recommending things to people that are inappropriate, right? This example isn't completely fake. Fuck. like these things are bad and they wake us up at 3 o'clock in the morning. And it's way better to have our Spark job say like, hey, this thing didn't go the way I was expecting it to. I'm not gonna push my model to production. Now, I mean, if you take the time to manually review the output of all of your Spark jobs, maybe this is kind of overkill. But one day, eventually, probably someone will come around and say like, I want real-time recommendations. I want this to get updated like every hour. And you're not gonna have the time every hour to go in and like look at your job and say like, is this new model actually pretty reasonable? So how do we validate our jobs? So I'm sort of focused on like validating things from the point of view of like looking at the outputs that we can get from Spark. But obviously, if you're producing a model for recommendations, you should validate the recommendations as well. And that's really super domain specific to what you're doing, so I didn't go into it. But sort of regardless of what you're doing, we can validate that our Spark job is behaving in the ways we're expecting it to. Spark has a lot of internal counters. They're not all super useful for validation, but I think that like the number of records we're reading overall, the number of bytes that we're reading in, if our execution time like skyrockets, that's maybe not a good sign. It's probably a sign that something's gone wrong. Or alternatively, if the number of records we're reading has like dropped, that's probably not a good sign either, unless you've raised a down round and all your users have left anyways, in which case no one really cares about your models. But we can use these things that are coming from inside of Spark to validate our job and make sure that it's sane. We can also use our own counters. How many people use accumulators inside of Spark? Okay. How many of people use accumulators for diagnostic tools inside of Spark? Ooh. Well, okay, so for those 4 of you, you can take your existing diagnostic counters and you can wire them up to a validation type framework, and you can automatically know what's going on with your job. For the rest of you, I'd encourage you to look at using accumulators and counters inside of Spark to sort of keep track of bad records, the number of times there's no recommendations, and things which could indicate a potential data problem. And then you can validate that these counters are not going significantly off the rails. So what does that look like? If we were one of those 4 people, it might look like this, where we're going to register an accumulator with our validation thing, and then down at the end we'll call validate. If you're one of the majority of people who don't currently use counters inside of your Spark jobs, it might look more like this, where we're going to say the number of records read should be somewhere between 30 and 1,000. So clearly not actual good production bounds, but like you might want to say, number of records I've read are in some range if you have some idea of the number of users you have. But like here, we could use the same rule here on the next slide, and we could say, the number of records I've read should be, roughly equal to the average from the last 5 runs, plus minus, 100,000 records. Maybe your company is growing really quickly, right? So we can write our rules both in a relative fashion and in an absolute fashion, depending on, who we are and what we're doing. So there's a bunch of, awesome related content. Testing Spark best practices from Spark Summit is a really cool talk, and it's up on YouTube, and there's some slides for it. Every Day I'm Shuffling, I was one of the co-presenters, so I definitely think it's a talk you should check out. But some of the testing stuff from this talk is sort of an expanded version of some of the bits from that talk. And it also has some really cool performance bits in it too, so if you care about performance, it can be a good talk to check out regardless. There's a blog post, Spark and Spark Streaming unit testing. If you do want to go ahead and do sort of the artisanal hand-rolled approach, that's probably the blog post for you, although it is a little out of date. Some of the stuff doesn't quite work in 1.4.1, but it'll get you started down the path. And then there's also a blog post which I wrote, which once again, as the author, I think it's pretty cool, but making Spark unit testing with Spark testing base easy. So it's pretty cool. It's on the Cloudera Eng blog. So most of what we've been doing is sort of looking at how these packages can help us write tests and write validation and avoid losing money, or users, whatever. So the Spark testing base is on my GitHub. SScheck is on another person's GitHub, and Spark Validator is on GitHub as well. They're all, well, the first two I believe are also on Spark packages, so it's really easy to include into your thing if you're building with SBT. It's really simple to add more Spark packages as dependencies. If you're not building with SBT, standard Maven coordinates apply, like, go have fun. You probably shouldn't actually use Spark Validator on a real production job. I enjoy not getting sued by large corporations. It's version 0.0.1, so please don't use it today. But if you want to, come and contribute to Spark Validator, or just use some of its ideas when you're writing your own validation, that's probably sort of a good place for it to be. And sort of the two things from Databricks, which are really great projects, and they're not super focused around testing our own code, but I'm a firm believer in hijacking other people's projects to my own ends to sort of base your stuff on our Spark perf and the Spark integration test stuff. And then Scala check down at the bottom. It's not Spark specific, but I think it's great sort of regardless for people living in the Scala world. And there's similar ports to other languages as well. Yeah, that's cool. So so future work. So as I sort of alluded to with the batteries not included slide, I think it's a little weird that all of the testing stuff inside of Spark is private, and you have to go ahead and use libraries to get sort of testing components or write them yourself. So I think integrating some of these things into Spark itself would be a really good next step. Probably Spark testing based first because it's more reasonable, and Spark Validator as time goes on and more people use the APIs maybe. I think better Scala check integration would be really good. That'll probably be happening. The SScheck people have been really helpful. And I probably want to add some reasonable prefab rules for people that want to do validation, about number of records read, not varying too much, and just things that you can safely copy and paste and not have to think too much about. I'll probably put some testing details into my next Spark book, which is going to be, I think, high performance Spark. I don't know what exactly the title is going to be. Probably 80% sure it's high performance Spark, but you should definitely look for it when it comes out and buy 6 copies. And on that note, I'll give you whatever you want if you do that. But more realistically, I do have a survey for people that came today who are testing with Spark or know they should be testing with Spark about what sort of things you would like to see in the future. It's bit.ly/Holden testing Spark in camel case. I would love it if you filled it out so much. It would be really cool if I got more ideas about things that people actually want to see, as opposed to just asking my stuffed animal. She doesn't help very much. It's possible that I'll bring some more integration testing stuff into Spark testing base. As it stands, I really think the best approach is to go with the Databricks one and sort of customize it, or if you have your own existing integration testing framework, just shoehorning Spark into that, because integration testing is kind of a nightmare. But if there's a lot of demand for it, I'll maybe do it. And someone has started contributing some Kafka integration tests, so that you can easily test your Kafka integration correctly with Spark testing base. So that's pretty much it for future work. Or as I like to say, okay, thanks, bye. Please fill out my survey. But yeah, now we've got a bunch of time for questions. There's a microphone for people to come up to and ask questions. Please don't ask me awkward questions. I normally try and not leave too much time for Q&A because it's stressful, but I didn't do a great job timing it, so we actually have enough time for you to ask me questions today, which is kind of disappointing. Do you want to go up to the mic? It's right over there so that people can actually hear what you're saying. That way you don't have to repeat your question.
Yeah, I think that's good. This is all great, but do you have any insight into how we can debug Spark ML? while it's working? Because those algorithms are not really that open. What's happening inside? Are we doing something wrong?
So the question is about Spark ML?
ML, yeah, I'm running Spark ML within like Spark streaming to Spark ML, let's say ALS or some algorithm. You're not sure if the algorithm is really working, something's wrong, but that's outside our control. So what's your insight in those problems?
Yeah, okay, that's a really good question, unfortunately. And that's kind of, okay. So there's a few things that we can do. I think really most likely validation is probably sort of something you should be using if you're using Spark ML, just in terms of like seeing the number of stages that have been run and like how many iterations to sort of convergence have been happening. That stuff isn't really super easily exposed, but it does show up in some of these internal counters. So we can actually like get at some of them through the Spark validation stuff, not so much the Spark testing stuff. So it's more like catching your ML model is poor before you push it to prod. And actually testing ML code is really, really hard. And I did not do that well in statistics. So like, you're on your own. But like, if you're not completely on your own, like we can work together if you want, but like I have largely stayed away from it out of the realization that I am not competent to do it, despite contributing to MLlib. But only in the like code bits, right? Other people do the math bits, and yeah, cool. Any more questions, or should we?
How about testing when Spark talks to different systems? Like, would you mock the external system? Do you pass in a mock client object? You have serialization issues there. How does that work? Because just testing out the strings that come in and out is one part of the
Sure. Yeah. So integration testing with Spark streaming is really complicated. And for the most part, I've myself have avoided doing it, but thankfully there are other people who are less lazy than I am. And if you want to like do integration testing with Kafka and Spark, that's also in Spark testing base. It's pretty similar, except instead of extending like the streaming suite base class, you'll extend like the Kafka suite base class, and it has a slightly different API. But you know, that's really cool for doing Kafka integration. And this works really well because like we can actually spin up Kafka inside of our JVM, and we don't have to like go and talk to a bunch of different servers to set up like a fake HDFS or something. But you know, if you want to test it with some other system which does require that kind of setup, you're largely on your own. And I'm sorry about that, but good luck. Cool. Okay. I think that's it. You should follow me on Twitter if you want more cute cat pictures. I'll be hanging around to answer questions one-on-one, probably out in the hallway. If you know people want to ask their Spark testing questions, but less publicly.